Hey class, I decided to do my presentation on the Rolls-Royce Trent 800. The engine operation of the Trent 800 is like any other turbine engine. The ram air is sucked into the front of the engine through the large fan. Most of the air is used for pure thrust as it is directed around the engine. The remaining air then enters the engine and is squeezed together by a series of compressor blades. As the air is compressed, the pressure of it increases. Then the fuel is added into the air, creating the fuel-air mixture in the combustion chamber, and then it is ignited. The exhaust is pushed out through the back of the engine, and this also helps create more thrust. And this also turns the fan in the front as well as the compressors. The Rolls-Royce Trent 800 is primarily used in the Boeing 777 family. The thrust of the engine is available from 75,000 to 95,000 pounds. It has an 8-stage intermediate pressure compressor and a 6-stage high pressure compressor. The intermediate pressure and high pressure turbines are single stage. The low pressure turbine is a 5-stage. It also has a single annular combustor liner that consists of 24 fuel nozzles. The Trent 800 has a 3-shaft high bypass ratio of 6.4 to 1 at cruising thrust. The length of the engine is 4,568 millimeters and the maximum radius is 1,524 millimeters. The fan diameter is 110 centimeters. The dry weight of the engine is 6,078 kilograms. The Trent 800 is the lightest engine on the Boeing 777. This engine is 8,000 pounds lighter than with the GE90, 5,400 pounds lighter than with the PW4090, and 6,500 pounds lighter than with the PW4098. This translates into more payload. It also has an EP package that helps save each aircraft an average of $200,000 a year on fuel. This engine is very competitive on all of its reliability indicators. The main disadvantage to this engine would be that the fuel oil heat exchanger needed to be replaced back in 2009. The NTSB issued an urgent safety recommendation for the fuel oil heat exchanger in the Rolls-Royce Trent 800 to be redesigned. A buildup of ice from water normally present in all jet fuel on the fuel oil heat exchanger restricted the flow of fuel to the engine, resulting in an uncommanded engine rollback. This occurred in 2 aircrafts. One was in cruise flight and was able to return to normal operation by following the checklist to recover engine performance, and the other was on final and crashed short of the runway. All aircrafts with the Trent 800 were required to have the new fuel oil heat exchanger installed at the next maintenance opportunity or within 6 months of the new design certificate date, whichever one came first.